Okay, this is given methane when methane react with oxygen from carbon dioxide and water. What is the name this reaction? What type of reaction this one? Neutralization reaction, combustion reaction, decomposition reaction. What type of reaction? Combustion reaction. Good. Combustion reaction. Rafi gave me answer. Okay. Why this is combustion reaction? Why this is the combustion reaction? Is the reaction is combustion reaction? Uh, Burning with oxygen, methane burning with oxygen. So this is combustion reaction. Okay. Calculate the enthalpy change. Uh, calculate the enthalpy change for this reaction. Given bond energies in the table, and draw energy level diagram for this reaction. So calculate the enthalpy change for this reaction given the bond energies given in the table, and finally you draw energy level diagram for this reaction. For this reaction energy level diagram, we need to know either it is exothermic or endothermic. When we find the enthalpy change, if we see enthalpy change is negative, we will understand exothermic reaction, and if positive, we will understand endothermic reaction. Delta H is the enthalpy change. Enthalpy change is the change of the reaction, change of the energy during the reaction is called enthalpy change. Enthalpy change is expressed by delta H. If the enthalpy change is positive, endothermic reaction. If enthalpy change is negative, exothermic reaction. Okay, this is the enthalpy change. What is enthalpy change? What is the expression symbol? Enthalpy change is expressed by delta H. This is enthalpy change is expressed by this sign delta H. Okay, this is the delta H. Okay, this is the enthalpy change. This is enthalpy change is expressed by delta H. If delta H is positive value, it is endothermic. If delta H is positive, endothermic. Okay, have you understood what is the enthalpy change? Enthalpy change is the change of energy during the reaction is called enthalpy change. Enthalpy change is expressed by delta H. If delta H is positive, the reaction is endothermic. If delta H is negative, reaction is so this reaction, if delta is positive, this is endothermic. Endo means in, thermic means energy. Here energy in. If delta H is negative, if delta H is negative value, negative, the reaction is exothermic. So at first calculate the enthalpy change. So now what is bond energy? Bond energy, like this is this is a methane CH4. Here this is a bond, 4 bond here, carbon hydrogen bond, this bond, this is bond. Okay, how many bond here? Okay, what type of bond? Carbon hydrogen bond, carbon hydrogen bond, carbon hydrogen bond, carbon hydrogen. There are 4 carbon hydrogen bonds. Is it a metallic bond, covalent bond, coordinate bond, dative covalent bond? What type of bond here present? Do you know what type bond here in carbon hydrogen? This bond? Huh? What? It is this one is non-metal. This is non-metal. Non-metal. What type of bond? Metallic, ionic, covalent. It is metal and non-metal is ionic bond. This is both is non-metal.
This is covalent bond.
Yes, covalent bond. Covalent bond. Who gave answer? Oh, Satman. I look. He's a excellent. Okay, Satman. I know this answer given, Satman. Okay, this is a covalent bond. Covalent bond. There are 4 carbon hydrogen covalent bond. Every covalent bond require certain amount of energy to break it. So every covalent bond require a certain amount of energy to break it. This is known as the bond energy. Okay, this is the bond energy. Now I am writing this bond energy. Write down this, your copy. Write down your copy. Write exercise book. Write down. I am writing also. This is slow writing. Energy, bond energy, bond energy. Sorry, bond energy. Every covalent bond requires energy. Every covalent bond requires a certain energy, certain amount of energy to break it. This is known as bond energy. Okay, this is the covalent bond. Here is a 4 covalent bond. So to break this covalent bond need energy, a certain amount of energy. This is called bond energy. Every covalent bond require a certain amount of energy to break it. This is known as bond energy. Okay. So today's question here. Have you written what is bond energy?
Yes, sir.
Okay, now I am starting question. Okay, calculate the enthalpy change for this reaction. Given bond energies, here carbon hydrogen bond energy is 413 kilojoule per mole, and carbon double bond bond energy is 498. Carbon oxygen double bond 743. Carbon hydrogen single bond energy is 464. This is bond energy given. Okay, This is the reaction. Okay, at first answer, I am writing the answer. Solution. At first you write the reaction. You will write the reaction. Reaction is methane plus oxygen from carbon dioxide and water. At first you write reaction. Methane plus oxygen. Okay, how much how oxygen is gas? From how much how many mole oxygen? Oxygen 2 mole. That no. Oxygen here 2 mole, carbon dioxide 1 mole, 2 mole here, 2 mole oxygen, and this carbon dioxide gas, and state of water. Now water state is gaseous state, that means it is steam, is 2O, sorry, is 2O. Okay, this is the gaseous G. You write in the at the end here. Here you write. I have no space. Okay, I have a space also. I'm writing here. This is G. Okay, then you write the bond during the reaction. Reactants. These are reactants. Reactants are methane and oxygen. And products are carbon dioxide and water. This is the products. Methane and oxygen is reactants. During the reaction, reactants bond are broken. Breaking occur in the bond of reactant, and here formation occur in the bonds of products. So here bond breaking occur in reactant, bond formation occur in the product bond formation energy. So bond I have, which bond are break, which bond are form. I should write this is bond this way. Then you write how there is a bonding you write here 4 carbon hydrogen bond. You write 4 carbon hydrogen bond here this way. These things you write. You will show this bond. Okay, this is the reactants. Here oxygen, we know oxygen carbon single bond or double bond or triple bond. Oxygen 1 molecule. Do you know how many, which type bond, single bond or double bond or triple bond in oxygen?
Double bond.
Yes, double bond. Okay, how many oxygen molecule? This is 2 oxygen molecule. So 2 oxygen molecule. Okay, one information should write this during the here bonds breaking occur in reactants. Bond breaking occur in reactant, and bond formation occur in the products. We know during the bond breaking, here bond breaking, energy is needed or released. Energy needed or released? Energy gained or released during the bond breaking? Is the energy released or gained during the bond breaking? Energy gained, energy দেওয়া লাগে. Energy need to supply, otherwise bond will not break. So energy need absorbed here, gained. Energy need. During the product formation, energy released. Okay, energy released. So what will be bond breaking is energy gained. So bond breaking is endothermic. Here energy released during the bond formation. So bond formation is exothermic. Here negative. You should write this information. This thing this is not answer. You should write side note. This is not answer, it is side note. Breaking bonds. This is side note, not answer is this. You don't write answer in the in the middle in the answer. You shouldn't write. Bond breaking bonds need energy. So it is endothermic. Making bonds release energy. It is exothermic. Okay, this is exothermic and endothermic. Okay, thank you. Okay, breaking bonds needs energy. So okay, so here at first you will find the energy bond breaking. So it will be endothermic positive. Okay, bond. Now you should write in bonds that need to be broken. This is endothermic. Endothermic bonds that needs bond. So how many bonds here? Carbon hydrogen bond. How many bonds? This is 1 2 3 4. Have you counted? 1 2 3 4. 4 carbon hydrogen bonds. 4. This is 4. 4 carbon hydrogen. I should write these things by this thing. And so how many bonds? 4 carbon hydrogen bonds. 4 carbon hydrogen bonds. So what is the energy here? 4 multiply. Here will be multiplication. I will put here later. Then multiplication sign. It is endothermic. So carbon hydrogen bonds. What is the energy for carbon hydrogen bonds? Look, have you seen this question? It is for carbon hydrogen bond is what the bond energy? Carbon hydrogen bond energy is 413 413. This is multiplication sign. This is 413 the 400 yeah. What happened? Why can't I write here? Okay, this is 400. How much this energy? 413. This is endothermic. This is a positive sign. We know bonds positive sign, so plus 413 plus 413, that plus 413. So what is the energy? Multiply this 4 multiply 413. Have you taken calculator? Multiply 4 multiply by 413.
1652.
1652. Okay, 1652 kilojoule. Okay, this is another. How many bond? This one done. This one done. Okay, now this one. Oxygen bond. Here how many molecules? This is one. This is one. 2 carbon oxygen double bond. 2 oxygen double bond. 2 oxygen sorry, 2 oxygen double bonds. That why have I cut this one? So what is the bond energy for oxygen? Oxygen is 498. So how many molecules? 2 carbon. So 2 multiply sorry, here it is. This is endothermic, so positive sign here will be positive for endothermic. 498 So what is the energy? Have you calculated? 996 kilojoule. So now calculate total bond energy. Total কত এসে? Total কত? Total কত? 2648 kilojoule. Okay, so we have done bond. This is done. Bond breaking done. I should erase these things, otherwise I will supply this one. Then during the exam you will do these things. Don't do this in the exam. I am showing these things. Okay, I should erase these things, otherwise I will give this one. Other student will write these things. I am showing this. I have finished for this. Don't do this. Some student write this. What I write without understanding, write everything. I am just showing this thing. I have complete this thing. But some students do this type activities in the copies. Okay, this. Okay, this is done, methane, and this one, these two done. I erase again. Okay, now we will go to the products. Products energy bond needs to broken or formation. Here formation occur. Our formation is exothermic release energy. So here new bonds made exothermic. New bonds made at is exothermic. I have already said this, why these things exothermic, because here energy is released during the bond formation. So new bonds is bond formation is exothermic because energy released during the bond formation. So here who bond I didn't write this is bond. Which bond here? Carbon hydrogen bond. Carbon hydrogen bond here. Sorry, this thing's not okay. 4 minutes, 10 minutes remaining. I'll take another meeting when finished. Okay, this that this is capital O. Okay, this is capital O, not okay. I am writing also this one. How many carbon oxygen bond? 1 1 2 carbon oxygen bond. Okay, here water molecule subadjustant. How many oxygen? This is carbon dioxide. Here carbon oxygen bond is 2 bond. Here is a 1 1 2. Here oxygen. Water molecule here is 2 water molecule. Water molecule is this is a bond there. Water molecule at the center is oxygen. Okay, I write this water molecule using this one. This one water molecule, hydrogen, oxygen, hydrogen. Okay, this is a 1 water molecule, but here is a 2 water molecule. I am writing another water molecule. So total bond is oxygen hydrogen bond is 1 1 2 3. Here is a in this molecule is 2 oxygen bond. Here is a 2 oxygen bond. 1 and 1 2. Here 1 and 1 2. Here 2 2 4 bond. Carbon oxygen bond is 2 bonds. So I am at first writing 2 carbon oxygen bond, double bond. 2 carbon oxygen double bonds. So here I write 2. Here will be multiplication sign. I take some space here. It is not possible by typing multiplication sign. This is not given the keyboard. Given also, but it is not. We don't use this sign. Multiplication sign. Okay, this is exothermic. Positive or negative sign? Okay, negative sign. What is the carbon oxygen bond? Carbon oxygen double bond energy is, we see this thing here, 743. 743. Have you seen? This is 743. 743. 743. And here it should give multiplication sign. I put this place for multiplication. Okay, so what will be energy? Multiply this minus 1486 kilojoule. Okay, now this bond finished, this one also finished. Now water molecule, two water molecule. How many carbon oxygen bond? Here is a 2, 1 and 2. Here 1 and 2. Total 4. 4 oxygen hydrogen bonds. Sorry, here I shouldn't write here. 4 oxygen hydrogen bonds. So 4 multiplication what is the bond energy? Do you know? Oxygen bond energy, oxygen hydrogen bond energy. Do you know?
Minus 464.
Minus 464. Minus 464. 64. What is this? What happened? This is okay. Here will be multiplication sign. Multiplication sign. So what is the total amount?
1856.
1856. kg. Okay, now what is total? Negative 342. So look, this magnitude, not sign. Look, magnitude, not sign. This is the 300. No. Okay, what is the enthalpy change? Enthalpy change, delta H. So enthalpy change, enthalpy change, okay, enthalpy change, and this is delta H. It is not possible to write by keyboard. I write here delta H. This is delta H. Okay, so here you write the this one. At first you write bond breaking energy. Bond breaking energy is, you have to write sign also. Sign for in this calculation you should write sign. When if we write 260 48, we don't need to sign at first, but during the energy enthalpy change calculation you must write sign, plus sign, minus sign. Okay, so it is 4 4 4 2 2648 2648. These things I can write by 2648. These things plus 2648. Okay, then plus this energy, bond formation energy. This is the minus, so I should write this bracket minus 3342 kilojoule per mole. Okay, what is the energy total? Have we calculated? This is a plus a minus a minus. That means minus 33. হ্যাঁ কত 600 694. Okay, this is the kilojoule per mole. So we have found the energy delta H, enthalpy change. Enthalpy change is negative. Negative value. This is the negative value. So what type of the reaction is the endothermic or exothermic? Exothermic reaction. Look, this is the exothermic reaction because look, this not sign. More energy is released. More energy is released when bonds are broken. When bonds are formed. When bonds are formed, then it's required to break them. So the reaction is exothermic. So the reaction is exothermic. Now we can draw the energy level diagram. Okay, we have find the enthalpy change. Enthalpy change is 498. This is the answer. This is the exothermic reaction. Now drawing the now draw energy level diagram. Okay, this is exothermic reaction. Reactant energy is more than product energy. Yeah. Here progress of reaction. Progress of reaction. Okay, this is energy. Here you write these things. Energy these are the reactants. Reactants. Here is the products. This is the exothermic. Airtel offer. Wow, kita ise. Nahi dan dilo ki 160 টাকায় 7 GB 7 din. Okay, this is so reactant is here. Reactant is this thing, methane and oxygen, CH4 and oxygen. I can write these things here and copy paste these things, copy paste. This is the reactant. Okay, this is the reactant. Okay, product is CO2 COH. You have to write. I can do copy paste here. Not because I have not easier writing here, so I copy paste here. This is the products. Okay, have you written? This is here methane, CH4 oxygen plus CO2, and here see oxygen, methane plus oxygen is reactant. Here carbon dioxide and water is product. The sign will be reactant to product, arrow sign will be reactant to product. This way you write reactant to product, right? And this it is not reactant to product. Okay, here delta H is negative, you write delta H. Delta H is negative. Koto is negative. Delta H is minus 600 694 dot to আমি এটা দিয়ে লিখব না minus 694 kilojoule per mole. Okay, this is the energy level diagram of this reaction. Ki polse question moddhe draw energy level diagram for the reaction. So this is title. You should give this title of this figure. This figure, the energy level diagram for this reaction. The energy level diagram for the reaction. একটু পরে এটারে তুলি হ্যাঁ okay, have you seen this energy level diagram figure, the energy level diagram for the reaction? Have you written?
Yes, sir.
Okay, this is energy. I have it is what it is MRG, should cut this. This is energy. Okay, now I am going to next question. Okay, now this the problem 2, this one. First one, use Born energies. This is given Born energy, carbon nitrogen Born energy is given. Using the Born energy in the table, calculate the amount of heat released or absorbed when the following reaction take place. In each for every say whether the change is exothermic or endothermic. Okay, I am doing the C, question number C. Okay, which one I will do? A, B, C, D. Say. Which one I will solve? A, B, C, D.
A, sir.
Okay, A. So I am solving A. Here don't say draw energy level diagram. So only you will find the enthalpy change. And there you say exothermic or endothermic. This is finish. Here is finish. Here. Don't need to draw energy level diagram. This is question criteria. Okay. Question say calculate the amount of heat released or absorbed. That means enthalpy change. enthalpy change, that is enthalpy change delta H, this is, and then you say either it is exothermic or endothermic, these things and these things. Okay, so at first we write the reaction, then we will write their bonds, how their bonds are formed. At first I will write the reaction, then we will write how this bond are formed, then we will do the bond that need to be broken, this is endothermic, then we will calculate new bonds made exothermic, then delta H, this plus, this plus, then we will say if more energy is released than formation, it will be exothermic. Okay, at first we write the reaction. Okay, this reaction I write. So this reaction is A, methane and bromine. Okay, methane, bromine, A. Okay, I am writing the reaction, this CH4 I didn't write state symbol, you write these things because there is a space, few space. Okay, hydrogen bromide, this Br, hydrogen bromide. Okay, now I write bond, this is a 4 carbon hydrogen bond, and I don't need to write this thing here, I am copy paste doing, you have to write these things because you can't copy paste. Here okay, I have done write these things, and my eraser, what is this here? Okay, now this is bromine bond is single bond, bromine single bond. Okay, here carbon hydrogen bond, this one carbon hydrogen bond, 2 carbon hydrogen bond, 3 carbon hydrogen bond. Here is a 1 carbon hydrogen bromine bond, bromine. Okay, here is 1 hydrogen bromine bond, 1 hydrogen. One hydrogen bromine bond, 1 carbon hydrogen bromine bond. Okay, now I am start the second step done. Now I write the these things, bonds that need to be broken, endothermic, এগুলো আমি copy paste করে নিয়ে যাই। You have to write, but bonds that need to be broken. Okay, this is the 4 bonds, and these things can be copy paste. This one also. Are you understanding this thing? Here is a 4 carbon hydrogen bond. 4 carbon hydrogen bonds. 4 multiply 413. We know 413. Carbon hydrogen bond is 413. So 4 this bond for this one, 4 carbon hydrogen bonds. So 4 carbon hydrogen bonds, 4 multiply plus sign, this is endothermic 413. So 1652 kilojoules per mole. Have you understood these things? Hello student. Okay. Here bromine bond is 1 bromine bond. 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 So this is one bond, not bonds. So 1 multiply what? This is plus sign because this is bond broken. So what is the bromine bond? 193. Have you seen this? 193. I write here 193. 193. Bracket close already. That means plus 193 kilojoules. Okay, what is the total? Calculate. Two and 3, 5. 5 and 9.
1845.
Huh?
1845.
1845. Okay, this plus hai. Plus kilojoule. Okay. Now we do the bond. Ki se ke amader kerna ki? No. Now we'll find. I find this thing finished. Bond broken finished. Now bond formation. Hai. Here carbon hydrogen bond is how many carbon hydrogen bond? 1, 2, 3 carbon hydrogen bond. 3 carbon hydrogen bonds. 1 carbon bromine bond and 1 hydrogen bromine bonds. At first I calculate 3 carbon hydrogen bonds. This is bond formation. These things I can copy paste. New bond made is endothermic. It is doing for your time saving. Already 54-minute video. It is not maximum will not see this one because long video. New bonds made exothermic. So here how many carbon hydrogen bond? 1, 2, 3. 3 carbon hydrogen bonds. 3 carbon hydrogen bonds. So 3 multiply. This is my multiplication sign the computer. 3 multiplication. Don't write it this way. You write your way. 3 multiply. Okay, I'll write later this multiplication sign. 3 multiply. This is minus sign. Exothermic ratio minus. Bracket I should close this one bracket. Okay, so what is the carbon hydrogen bond? So we know 413. Why have I 413? 400, sorry, 400, 413. Here multiplication sign. So what total?
Minus 1239.
Minus 1
1239.
39.
Yes.
39. Okay, okay. Here in this compound 3 carbon hydrogen bond, 1 carbon bromine bond. So 1 carbon bromine bond I write here. Okay, bromine bond, carbon bromine bond, what is the energy? Carbon bromine bond, this is 290. Okay, 290 I write 290. I should remember this. 1 carbon bromine bond, that is 1 multiply multiplication sign minus 290, 290, close multiplication sign. Okay, what is the total? Equal to 290. 290. It is not adjusted, na এটা আদি দেখতে হবে. It should write 290. Okay, 290 kilojoule. After এসে এখানে another product, hydrogen bromine, hydrogen bromide. Arya Basharat, Arya coming sound from Arya Basharat. Okay, hydrogen bromine, this bond, hydrogen bromide bond. Okay, this bond also formed. Hydrogen bromide bond is 366. So here also one carbon hydrogen hydrogen bromine bond, 366. One hydrogen bromine bonds. This is also 1 multiply, this is space কত এই কত বলি গেলাম আমি 300. What is the bond energy for? Have you remembered this one? Not. Hydrogen bromine bond, I have seen here 366. 66 multiply, this is the equal sign. Okay, okay, what total? Oh, this is the 3 6 kilojoule. Okay, what's total amount? Have you calculated?
Minus 1895.
কত?
Minus 1895.
1895 kilojoule.
কি হবে স্যার কি হবে?
Okay, we have found the enthalpy change. Enthalpy change is minus 50 kilojoule per mole. Okay, have you understood? Minus 50 kilojoule per mole. Now next topics say whether the change is exothermic or endothermic. Here energy released is more in the bond formation than in the bond breaking. So bond releasing energy is more, so it is exothermic reaction. So I can copy paste these things also. More energy is released when bonds are formed than required to break them, so the reaction is exothermic. More energy is released when bonds are formed. More energy is released when bonds are formed than is required to break them, so the reaction is exothermic. Okay, have you understood?
Yes, sir.